Well, welcome everyone to our bi-monthly Innovation Network webinar. My name is Jared Leake. I'm the CEO of the Australian Alliance for Energy Productivity, or the A2EP as it's widely known. I'd first of all like to start off with acknowledging the traditional owners of where I am living and broadcasting from in the northern suburbs of Sydney, that being the Darramaragal people. And I'd like to pay my respects to the elders past, present and emerging. For those of you that are new to A2EP, we are a non-for-profit organisation funded by members who share our mission to double Australia's energy productivity. And for those not familiar with energy productivity, put most simply, it's more dollars from less megajoules. We try to make this happen by driving transformational change. We do this in a few different ways. A lot of it is through coordinating government programs that connect end users, researchers, consultants and technology providers. We also prepare publications that help guide public policy and investment decisions, as well as running webinars such as today. At A2EP, we pride ourselves in taking, not just in doing roadmaps and reports, but making things energy productivity become a reality. And right now we're doing that with ARENA funded program on process heating, which is a part of the reason why we're here today, and a little bit more on that later. Today we have a great program for you. We'll start with an update from Matt Walden from ARENA. We'll see how ARENA sees the bioenergy future. Then we have Gemma Harrison from Endeavour Group and going to take us through the drivers for the biogas industry. And then I'll give you a quick look at what we're doing with ARENA on this process heating study and how that's impacting potential impact for Australian industry and manufacturing. After that, we'll go through how you make biogas, what you do with it to generate electricity and heat, and then how you would go about operating and maintaining a biogas plant. And to do that today, we have three great speakers on the technologies there. We've got Richard Goldberg from Gaia Envirotech, and then we have Craig Dugan from Optimal Group, who's going to take us through gas turbines for burning and using the biogas. And finally, we have Edwina Beveridge from Blantyre Farms, is going to take us through how to operate and maintain a biogas facility. After that, we'll take a look at the Commonwealth set up a research facility known as a CRC, Cooperative Research Centre, the one called Race for 2030, the largest ever CRC set up, and they have a specific stream dedicated to driving on-site biogas. We'll hear from the CEO, John Judson, on that one to see how his organisation is helping biogas projects move forward. Fairly tight program today, so we'll go through the questions after each speaker if we have time. If not, we're going to have most of our speakers hang around at the end for an extended Q&A after 5:30. So if you'd like to join us after that, absolutely feel free. In terms of the Q&A, so in this webinar format, you've got that Q&A button at the bottom of the screen there. Just feel free to type in your question there. And with that, then others can upvote your question as well. And so we'll answer those in order of which has the most upvotes and get to them. And if we don't get to them after each speaker, we'll look at getting to those questions at the end of the program after 5:30. So this presentation will be recorded and distributed as well, so no need to take screenshots or extensive notes or recordings. We'll send that out for you sometime next week. So without further ado, I hope you've got all comfortable with your afternoon cup of tea and are ready for our broadcasters who are no doubt broadcasting from home. So let's hope we have a dog interruption or a cat interruption, maybe the kids coming home from school, and to make us keep things nice and lively. But with that, Matt, I'd like to hand over to you and give us a feel for what ARENA sees of bioenergy going forward.
Great, thanks, Jared. And I'll just maybe if you wouldn't mind just confirming you can hear my audio and visual okay. Yep, so thank you very much.
Absolutely can hear and can see that slide as well.
Excellent. I'd like to say this is my drab home office, but I'm unfortunately in the office today, so don't hold that against me. But thank you, Jared, to yourself and A2EP for the invitation to come along and have a chat today. As Jared mentioned, by background, Matt Walden is my name. I am in the business development team at Arena, and very proudly have carriage of our bioenergy subject matter or work stream. And one of the very important areas that I'm managing and looking after at the moment is Arena's role in delivering the bioenergy roadmap, and that's predominantly what I wanted to give a quick update to this audience on today. And I think just having had a quick scan of some of the attendees, I know a lot of people have had various levels of input into that process, whether it be through consultation or submission. So thank you very much for that assistance as well. But just in terms of the bioenergy roadmap and people who want a bit of the backstory, it was identified by as an area of interest by our minister responsible for Arena, Minister Angus Taylor, and going back some time ago, he requested us look into the development of a bioenergy roadmap to build on the portfolio that we had developed over time in this sector, and it is a very healthy and well represented one. But again, a number of areas of focus stressed in that scoping, and obviously picking up the interest for decarbonisation, biogas, biofuels, electricity, and the like. So quite a broad remit for us to go away and do our investigation of. So we are well and truly underway in the process now. We've retained the consortium of Deloitte and ENEA to assist us with that work, and both organisations I expect are well known to a number of the participants and have done a lot of work in the bioenergy and renewable energy sectors more generally. So we're very proud and very happy with how we're working together with them. And we have developed, I suppose, a bit of a framework for delivery of the roadmap. So obviously we've gone through a lot of preparation, a lot of consultation to pull together what we do and don't want to look at and what we want to try and achieve and not achieve. We've gone through some fairly extensive consultation, which I'll give some context on as well. Heard a lot of views and perspectives, and again, all of them different lenses. And again, I think that's very important. It is very much a sector that attracts a lot of interest from a lot of different counterparties, whether it be people with a unique or opportunistic feedstock resource, access or ideas from a conversion technology point of view, and of course end users and a broad remit of stakeholders that sit around that, including very importantly communities and social license, which is critical in this sector. So as I said, we're concluding a lot of that work, that I suppose report development work now before we move into the drafting phase, and then look to finalise that process in coming months. But the anticipation is we will look to ensure that we have a high degree of alignment and support to the government's technology investment roadmap. So very integral pieces of work. And just a couple of key numbers. So 9 consultation workshops held, 17 direct interviews with parties of varying interest in the sector, 147 online written submissions, so very much exceeded our expectations on that front. And we actually had to allocate an incremental amount of time to make sure we got through all those in significant detail. And obviously very significant public representation at our Zoom sessions. And it's interesting actually, just a bit of an aside, and Jerry, pick up on your theme. We originally had planned and scoped to attend a lot of regional locations for this, because obviously from a resource point of view, extremely critical. The manufacturing sector also can be quite regional in nature as well. And obviously with the impact of the prevailing circumstance, had to rethink those plans. And we found that the Zoom platform that we're using today has, if anything, I think strengthened some of the views and insights we've had. So just a slight, I suppose, little learning that we've picked up along the way. So fantastic. So consultation process, and we did this to sort of pick up some key themes at every interaction we had, or every formal interaction we had. We asked some key questions and basically put to people, you know, why is this sector important? What does it mean to you? What are the drivers? And here's I suppose a bit of a visualization of the tool we use to capture some of that. So obviously the concept of decarbonisation it was front and centre. The reuse or re-leveraging of waste or low value products, the regional point which is flagged, the fuel and energy security, and so forth. So again, I think common to a lot of people's views, but I think important to flag that this was quite a broad cross section of people that these questions were put to. So just a slide, I won't go into detail here. Again, really saying that we have gone into and put a lot of thinking into how we've come to look at this. So what are the various pathways, the resources? How does public policy overlay? What social responsibility is there? Commercial drivers as well. So I think the commercial challenges in this sector, depending on where you're looking, again, is absolutely critical. So again, I think, this slide, again, not going into the detail, is very much designed to say it's been a very broad, encompassing framework that we developed with the two consultants to ensure we've got a full perspective of the sector. A bit of background. So we asked the consultants to go away and do a bit of research internationally. And again, I think I am personally always very skeptical about pulling international benchmarks because of the very, very different landscapes that exist in Australia to other jurisdictions. And bioenergy is obviously quite a developed concept, particularly in, say, Northern Europe for reference, or even some Northern Asian countries. But very important to flag that very, very different circumstances and prevailing economies, prevailing temperatures, climates, etc. That, again, you've just always got to be cognizant of drawing those international comparisons. But nonetheless, I think a very interesting reference to understand what's driven the take up of bioenergy in those relevant sectors. So the modelling approach, and a large part of what we're doing is current and forward economic modelling. So we've leveraged the team at Deloitte Access Economics to do this work for us, and the team that did a lot of the hydrogen strategy modelling work, really looking at both demand and supply side. So what are the levers and mechanisms that will support the take up of various streams of bioenergy under different prevailing circumstances. So, for example, cost reduction, movements within industry around technology reduction, cost of capital reductions, policy changes, etc., to really drive and understand, I think importantly, what does a sector look like today? What does today's trajectory look like? What could it look like? And I think that's the important one, is what could it look like? Understanding what that benefit is in terms of job delivery, regional investment, economic activity, and obviously then decarbonisation as well. So again, I think important to flag, there's a BAU concept, but also there's this opportunity to leverage a lot more. So what are the pathways that we've focused on? Again, I think, slightly generic in terms of the context here, but these 4 subject matter areas here are basically what we've broken this down to try and simplify it. So industrial heat, again, self-explanatory, and a range of technologies that can be used there. The electricity sector, and probably one of the bigger take-ups of bioenergy at the moment, for example, the sugarcane sector. Transport, so obviously renewable fuels will play a critical role in certain sectors going forward. The aviation is a very interesting one that we've had a lot of feedback on, and we're investigating a lot around what are the various targets that sector is looking at, what are the range of conversion technologies, what's the cost reduction, and therefore understanding, what time horizon is something like renewable aviation fuel a realistic proposition. And importantly, and for today's session and framework, and a lot of the speakers will cover, is bioenergy as a decarbonisation tool for the gas network. What role does biomethane play? How can it support the gas network? How does it support and sit alongside renewable hydrogen, for argument's sake? So again, all tools that are relevant to support that decarbonisation story. So I think I might be at the end of my slides there. So I might, I'm going to pause there, and I might be at the end of time as well. So if I could, Jared, I'll pause there and welcome any questions.
Sounds good, Matt. Thank you. And no questions come through on the Q&A at the moment. But since we'll keep the things a bit tight, I'll just acknowledge that it's great that Irene are looking at this, and you've got to think a long way ahead, don't you, to stop these sort of structural issues stopping the progress of this, with gas pipelines going across so many different borders and what have you. So great that Irene is looking at this, and I'll put my vote in for the benefits for regional development, if I may add to that large chunk of support there. Excellent. Thanks.
Great. Thanks, Jared. Again, thank you for the opportunity to attend today's session.
Great to have you. Thanks, Matt. Good. Yep, no questions coming through. So yeah, again, feel free to pop them in the Q&A down the bottom there and upvote those as you see. With that though, we'll hand over to Gemma Harrison. So Gemma, if you'd like to share your screen and take us through what you at Endeavour has been seeing as the main drivers for biogas. We can see this.
There we go.
Here we go.
Thanks, Jared. So yeah, my name's Gemma Harrison and I'm the Sustainability Engineer and Business Development for Enwave Australia. Enwave is an energy infrastructure owner and operator. We own and operate district energy schemes across Australia and own TasGas, the Tasmanian natural gas distribution and retail business. And we do see biomethane as playing a key role in Australia's future energy mix. And so I'll talk today about some of the key drivers for this. So biogas from anaerobic digestion, wastewater treatment and landfill can be upgraded to biomethane, which has similar composition to traditional natural gas. And this is typically done by removing hydrogen sulfide and separating the methane from carbon dioxide, oxygen and nitrogen and leaving a pipeline quality gas. The key drivers for this include emissions reductions. So there is a push to move away from emission-intensive fossil fuels to reach the Paris Climate Agreement target of 1.5 degrees below pre-industrial levels. And this is driven by an increased demand from consumers who are conscious of carbon footprint, and it's also been driven by shareholders in the move away from fossil fuel investments. Biomethane is a source of dispatchable renewable energy, and the gaseous fuels do fill a niche energy demand that's not met quite as effectively with electricity, particularly for high-grade heat. And it is attracting increasing attention from international investors. So many overseas project developers are viewing Australia as a bit of a gold mine, in that it's an untapped market compared to some other countries with an established biogas industry. And many of these investors do have the view that a price on carbon in Australia is inevitable. It's more of a matter of when and not if. Some of the current barriers to biomethane uptake in Australia at the moment include a lack of incentive supported by the government. So these things include renewable gas certification schemes and green gas targets and feed-in tariffs, and potentially even excise tax incentives for the vehicle market. And hopefully some of these are the issues that we'll see highlighted in ARENA's bioenergy roadmap. There's also a high capital cost associated with the upgrading equipment. So it does require economies of scale to get to a feasible business case, particularly at the moment without additional financial support. The cleaner the gas needs to be in terms of removing oxygen and nitrogen to meet pipeline specifications can tend to make the upgrading process a bit more expensive. And there's also a cost associated with getting gas into the network, which is an issue particularly in the agricultural sector, where biogas sources are generally more distributed and at smaller volumes, and can often be far away from a network. But this is beneficial if there is a demand for gas on site. So biomethane that meets the Australian pipeline spec can be safely injected into the gas network, or it can be transported to customer sites and supplied behind the meter by a mobile pipeline, which involves compressing the gas into high pressure containers and transport to a customer site by truck. And this is something that Enwave do in Victoria for natural gas and is directly applicable to biomethane. And as Matt mentioned, biomethane can also be used in transport. So Scania, Iveco and Isuzu all have ranges of new natural gas vehicles that are ready for the Australian market. And biomethane can 100% replace CNG in these vehicles. And these gas trucks and gas vehicles do produce much less carbon dioxide, particulate matter and noise and NOx emissions compared to diesel. So it does help improve air quality. Which is why a lot of European cities, such as Paris and Madrid, have actually banned diesel combustion engines in the capital cities over the next few years. So CNG and biomethane vehicles are increasingly in demand in these markets, and the technology is available at a cost comparable to diesel. Biomethane also provides an additional source of revenue for the biogas producer. So with the RET scheme coming to a close, and there's some limitations to the ACU scheme, limited to around 7 years, biogas sales can provide long-term revenue while meeting the carbon abatement requirements, so as an alternative to flaring, and can provide an avoided cost if the gas is used on site to displace any brought-in fuels such as LPG. So the agriculture in particular can create a circular economy by leveraging their waste streams to capture the energy and put back into their site demand. So whether it's electricity, heat, and transport. And some international examples. So in Canada, Quebec have set greenhouse gas emission targets to reduce their emissions by 20% below 1990 levels by 2030. And in doing that, they've mandated that by 2025, all natural gas distributors would have to source 5% of their natural gas resources from biogas sources. And in Denmark, they currently have 166 biogas plants, which are a mix of wastewater, landfill, and industrial food waste and agriculture. In 2019, 9% of the gas used in Denmark was from renewable sources, and that's expected to jump to 30% by 2030. And this is supported by some national environmental frameworks to help de-risk investment in the bioenergy sector. So yeah, I was trying to keep it short and snappy to fit into 5 minutes. So if you have any questions, then please feel free to contact me. Thank
Absolutely.
you.
Yeah, fantastic. For 5 minutes, you got through a lot. Well, thanks. You mentioned that the technology for the trucks is competitive with diesel. We've got a question here from Andy Gilbart saying, is these overseas biogas processes, the cost competitive with fossil fuels, or are they subsidised? Are you aware of that?
So the biogas processes, so to produce the biogas, generally will be, many are subsidized, so like through government supported programs. But yeah, we can produce, we've been looking at a lot of projects in Australia, and because of the higher price of diesel compared to traditional natural gas, if we're using biomethane to replace diesel rather than natural gas, and we can get to quite a competitive business case there.
Okay. Question here from Kylie Hargraves. Are you able to talk about the potential for cooperative biogas projects like multiple dairy farms or sugar farms getting together to harness their waste energy, and what do you see as the barriers for that?
So this is one of the business models that's been quite popular in Denmark, to have like a cooperative agriculture biogas projects. I'm not really able to talk much on that, more the upgrading, the actual like technology associated with the biogas upgrading, rather than the collective business model used for the anaerobic digestion.
Okay, oh, gotcha. Now a question here from Sean asking, is biomethane powered transport, how would that compare with, say, electric vehicles? Have you done any comparisons on that one? Yeah,
so biomethane is effective in heavy transport, say for trucks and buses, up to 450 horsepower. So above that level, that's when renewable hydrogen like fuel cell vehicles will come in due to restrictions in gas, the torque and power. Whereas compared to battery electric, we'll see that that's taken over the passenger car market. There are issues with battery electric for trucks and buses at the moment due to the weight limitations. Yeah.
Okay, good to hear. Here we go, another one related to biomethane competing with hydrogen, replacing diesel. So you said clearly competitive with diesel. Any thoughts on hydrogen at all? Maybe we're $2.
Where was that question?
That was a question from Sandy Sue.
Yeah, so I think for the heavy truck market and bus market, below 450 horsepower is where biomethane will be very competitive with hydrogen, especially now. It's already at a price competitive with diesel. But for that, the kind of heavy horsepower trucks, that's where fuel cell vehicles and passenger cars is where fuel cell vehicles will dominate, I think.
Good. Yep. And as Sandy said, that's all clear. Thank you. Good one. All right. Thanks very much for that, Gemma. Much appreciated. I think we'll move on now and look at how biogas is working in a industry context and the process heating that we've done with ARENA. I think we've got the slides coming up for that one. So this is we'll take a look at this just from an industry process heating perspective. And if we click through as we click through the animation there, you'll see this is the breakdown of energy consumption for Australia. A huge chunk there, 44% going through industry. Of that, 52% is used for heat. And the majority of that is right now coming from fossil fuels. If you break down where that's used in the process heating by the temperature it's produced at, I'll just go back one there. You'll see that most of the demand there is in high temperatures, that's 800 degrees, and that's a lot of that in this sort of heavy industry, alumina and non-ferrous area. But there is a big chunk of that if I take the 150 to 250 degrees and below of process heating, that is in a range where things like heat pumps can be used. Certainly at that range of 100 degrees and below, things like heat pumps. And this is a lot of what the studies we've been doing with ARENA over the last couple of years is implementation of those. Biogas comes into more interesting in that middle phase of temperature requirement, where heat pumps start becoming uneconomical, and solar thermal as well as economical in that area. But this is one of the main reasons why we're looking at biogas, is because that sort of middle chunk there, say between 250, 800 degrees, is where we think biogas is going to have a very big role to play. If we look at go to the next slide here, this is the map from ARENA that says where the different technologies can be used. The second one down, bioenergy, that's what we're talking about today, biogas. The first one, electricity, that's largely with the likes of heat pumps, ohmic heating, microwave heating, radio heating, and what have you. For those that have seen my background here, that relates to solar thermal. This in the background for myself is the solar thermal collecting plant for Sundrop Farms, the tomato producing farm there in Port Augusta. Another one there to look at, geothermal, a little bit limited here in Australia, and then finally hydrogen, which certainly has a long way to go. If we go to the next slide, we're looking at the results of the process heating studies that we've done. So with A2EP has conducted about 20 feasibility studies over a range of different industries and come up with a range of different results here for changing from using fossil fuels to renewable energy heating. You can see there's quite a big cluster in the bottom left there in terms of the size of the projects we're looking at, around about $1 million, and with paybacks in that sort of 4-year range. Those projects were largely either heat recovery projects or looking at heat pumps. There's a cluster in the middle there where you looked at the yellow and brown sort of colours there. Those projects were highlighted by lower utilisation. So we had a few of those were heat pump projects again, and utilisation getting below sort of 50%, saw the economics really trail off for those, and the paybacks heading more towards 8 to 10 years. We did have one case looking at a solar thermal on the top right there. We think with some more investigation and some optimisation into their process, that's the paybacks for that is going to come way down. But yeah, this is the main results that we've had so far from the process heating studies. I think I've got one more slide on that one. Yeah, and this is what we're seeing is see these projects going to fruition. Number one, we have to say we see the companies that are moving from pre-feasibility, feasibility through to implementation. Number one has to be that commitment to net zero, where they're looking at very much a strategic issue here, where they have a social license and they know that they need to go to net zero for in the future. Next issue we've seen is about change management, and it does require commitment at all levels, as well as site champions. So the communication coming from that we are heading towards net zero, that's great to go through all levels of a business, but you also need a site champion that's going to be looking after this solar thermal project or this biogas project on site to really drive the project forward. We did see a good results there, showing from heat pumps to say that if you couple that with thermal storage, an excellent opportunity for demand flexibility. So not only are you getting good paybacks, as it says in the next dot point about paybacks of less than 3 years just on energy, but if you look at the demand flexibility options where you can use that cheaper solar during the day, then that really does accelerate the paybacks for such projects. Finally, we also noted that it was a very important that to help projects go ahead if this was coupled with other non-energy benefits. Say, for instance, there was a production limitation and the process needed some more heat or what have you. We certainly saw that was a really good enabler to see projects go ahead. So production expansion or debottlenecking as well. So there are a lot of the main studies. There'll be a link in this presentation slide that you'll get shows you about the results for that. But those studies are showing some great results, and we continue to work through some more feasibilities with those as well. Good. So that's it on the ARENA and the process heat studies. Now let's get into biogas and how to first of all make biogas. And we've got Richard Goldberg here, who has the newer technology, which I think is going to make it much more accessible for many more players who want to have biogas on site. Richard, I'll hand that over to you.
Thank you, Jared. So thanks very much for the opportunity to speak today and to talk about anaerobic biodigestion, and in particular the Gaia Envirotech modular biodigester. So I wanted to start off really with a quick introduction to Gaia Envirotech. So Gaia Envirotech is a division of Gecko Systems, who are a Ballarat based company who have been manufacturing energy efficient mineral processing equipment for over 20 years now. And during that time, they've built up a strong core competence in modular plant design and also slurry movement. And through a collaboration with a local piggery who'd been running a biodigestion system for 25 years or so, we've developed a biodigester that is designed to be low cost and versatile so that it can be used locally on site and be a commercially viable solution, waste management solution for doing that. So a couple of words, just what is anaerobic biodigestion? So essentially it's the breakdown of organic matter in the absence of oxygen. So there's microbes, they break down organic matter, be it manure or food processing waste or food waste, that generates biogas, which is mainly methane, a fair bit of carbon dioxide and a few other gases. And then biodigestion system will normally capture that gas, clean it, and then utilise it as some form of energy production. That could be electricity, heat, or just as gas for use in a local system. And as you can see, here's a picture of our modular system, and how it differs from a standard system is the two stacks you can see there in the foreground are the digestion cells. So this is where the organic matter is broken down by the microbes. And in a traditional biodigester, that would be a single large tank. And beyond that, you can see some gas processing outside of another cell, which contains some utilities and also a generator that runs on biogas, and beyond that is some gas storage so that the system or the energy generation can be run on demand, so the energy can be stored. So, and as you can see, the system is designed using shipping containers as the kind of core structural element, and there's a reason for doing that is twofold, but one is really to take advantage of the huge infrastructure that exists today in manufacturing shipping containers and also in transporting them. So that helps with our aim of making a low-cost system that is locally deployable. And the other thing that's obvious from that picture there is that the system is modular. So, and I'll discuss that in more detail later on, the benefits of that. Sorry, I'll just move that. So the general benefits of why someone would want to introduce biodigestion into their business, it often sit around waste management. So there's the reduction of organic loadings in waste, and organic loadings are often what causes odour problems or wastewater problems. By capturing and burning methane, you're destroying a very potent greenhouse gas. So methane's 20 times or more than 20 times worse than carbon dioxide as a greenhouse gas. And it also produces in the digested material a fertiliser which can be used as a byproduct of the system. So it delivers on-demand renewable energy in a format that can be chosen. It also provides the user with green credentials, and with the system, if it is low cost, which the Gaia system is designed to be, it means that you can enable the system to be utilised locally. And that has several benefits in that the energy, for instance, can be used behind the meter, and also it allows the end user to be in total control of the feedstock that runs the biodigester. So the sort of value streams that a biodigester can generate are varied. So as I mentioned, there's a fertiliser product that can come out the back end, and depending on who the end user is, they may use that on their own farm or sell it. Capturing biogas, in particular methane, effectively reduces carbon footprint and therefore can be eligible for receiving carbon credits. Generating electricity or heat through burning the methane can provide renewable energy credits, and then the power can be used either behind the meter, or if there's more power generated than required, it can be exported. So there are many kind of financial returns that come from a biodigester, but there are also many others which a lot of customers talk about, which are bigger picture items. So, and these evolve around more implementing better waste management practices. So these can result in reduced environmental impact, operation costs. That can often lead to an ability to increase, say, herd size or production size if waste management was a limiting factor, and really it delivers a social license to operate for many people. So as I mentioned, the Gaia system is modular designed, and there's a lot of benefits that come from having a modular design over a large single tank system, which has been traditionally used for biodigestion. So the first of these is that the system can start off to meet the size of a business, and cells can be added very easily to increase treatment capacity, and also to meet the kind of financial investment of the business, capability of the business. And modules can be added as different forms of energy are required. Being modular, it's very low cost to build, or lower cost to build, and low cost in terms of delivery and installation. It's very configurable and has a small footprint, so this means it can be installed locally. And the other benefit is around, or major benefit, is around the process. By having a modular system for the digestion cell, this allows the process to be optimised more efficiently than it can in a single stage system. So, and what that means is the biodigestion process can be looked as 3 or 4 sort of independent stages, each of which really has a set of conditions in which it's optimised. So, for example, each of those conditions may really like to be sitting at a slightly different pH, and if they're all going on concurrently within a single tank, the efficiency of each of those is compromised to some degree. However, if the system's multi-staged, as in each stage of the process can be separated into separate containment cells, then, for example, in this case, the pH can be tuned within each of those cells, or there are many other parameters can be varied. For example, the cell temperature could be varied between stages. Additives could be selectively added at different stages. The residence time at a particular stage can be adjusted by configuring the cell flow, and also even if there's multiple feedstocks, these can be tuned to provide optimum performance. So the modularity of the system not only brings a low-cost design that can be easily scaled up with need, it also helps optimise the biogas production and therefore the value generation that can be achieved from the system. So when we were designing the Gaia system, we used design-led thinking and sort of, which involves also voice of the customer thinking. And what that means is it really is looking at the end user requirements and seeing how we can satisfy those. And a couple of things that really came out to us was that the end users of the system, be they a farmer or a food producer, are not really interested in operating a biodigester. They're more interested in focusing on their core business. So that's one thing that was very evident. Also, that a lot of these businesses are located in remote locations, and because of that, they have limited access to specialised labour. So as a result of that, we ensured that the system is highly automated. This is something that we do with our mineral processing systems, and so that there is very little intervention required to operate the system. If need be, it can be monitored or even controlled remotely. So that can be done by Gaia experts if it's required. And also the touch time on the system is very low. So the system shown in that picture there was running for 18 months, or has been running for 18 months or so. And really the touch time on that is a walk around every 1 to 2 days. And it sends out electronic logs and will email or inform you electronically if there is an issue or it requires attention. So the other evident thing that came out of the end users was that they not just wanting a biodigester but a waste management solution. So often that involved engineering pre-treatment. So for example, in the slide shown there, there's a piece of mining equipment there, but that was used to extract sand, bedding sand from a flush system used at a dairy farm, and that system could be used, reused again. Sorry, the sand could be reused again. And also often there's dilute feed streams which need to be enriched. So for example, through a process like dissolved air flotation, and the that to produce clarified water, which again can be reused by the business, and the enriched feedstock fed into the biodigester to make green energy. And again, the output of the biodigester can be post-treatment applied to either produce a, well, to meet the requirements of the end user. So for example, some users are happy to just spread the output as fertiliser on their own paddocks. Others like to have a biosolid product that they can export. So just a quick example there of an operating system. This system here is in Bungaree, which is located near Ballarat. It's at a robotic dairy. That dairy has a shed which contains 300 cows that are automatically milked every day, and the system collects 24,000 litres of manure in a pit next to the shed. And the biodigester you can see in the background there automatically collects the manure from the pit. It controls it on the level of the pit, feeds it into the biodigester, collects the biogas and scrubs it, ready for energy production, for use in either a generator or a boiler, and it separates out the byproducts for soil conditioner and fertiliser at the end of it. So just a quick word, I wanted to talk about the ability to introduce new feedstocks or different feedstocks across food and agricultural industry into the system. And a group of people interested in introducing biodigestion into the food and agriculture industry got together and formed a consortium. There's Tasgas there, Booth Transport, and a couple of primary producers, Meredith Dairy and Trigg Farm. And the aim of that project, that was supported by Food Innovation Australia, FIAL, and the aim of that project was to fast track the ability to predict and optimise new feedstocks into multi-stage digesters. And the deliverables from it were to develop a lab capability, which was matched to full-scale biodigester performance. And it could also develop pre-processing solutions for different types of feedstocks, to develop and document best practices for multi-stage biodigester operation, and also to manufacture and provide an open access demonstration plant for validating scale up. So the outcomes of that project are briefly shown on this slide. You can see the demonstration plant. That's a 75,000 litre 3-cell demonstration plant shown there on the shop floor. There's a picture of the laboratory in the top right hand corner, and a proof of concept of a laptop multi-stage biodigester in the bottom right there, which will be used to optimise multi-stage biodigestion systems. So the lab's been set up to evaluate feedstock, look at pre-treatment developments, and also how to optimise the biodigester. And a couple of examples I wanted to show here. We're just in the bottom right hand corner. You can see the effect, for example, of post-treating the biodigester output. So depending on the use, in that case, you can see the left-hand side is the output. The right-hand side, we've clarified the water, which is what's in the jar there, and extracted biosolids off for fertilisation. The top right-hand corner there shows some equipment that was designed in-house by our lead microbiologist for measuring biogas production rates. And the graph there shows some biogas production rates for a couple of different feedstocks, in this case cheese whey and milk permeate. And the type of information that can give us, you can see the biogas produced as a function of time, which is days across the bottom there. And for example, for the cheese whey, you can see the retention time for the feedstock, or how long it needs to be in the biodigester, is defined by when the biogas production rate plateaus off. So that really determines how long the feedstock is in the biodigester for, and therefore the size and capital cost of the biodigester. And the height of that tells us how much gas will come off, and therefore how much energy we'll be able to generate. Other information we can get from that sort of work is, you can see there for the milk permeate, that there was a rapid rise in the biogas production, which plateaued out when it was overfed. So this provides information on how to optimise the feed rates, etc., into the biodigester. But all of that information, the aim of having it is so that we can put together informed business cases for people to make decisions around investment and implementation of biodigester technology. So just a quick word before I finish on the demonstration plant. So it's currently installed and commissioned at a cheese factory in Southern Australia. It's there on an 8-month deployment, and frustratingly just waiting for the easing of the COVID-19 pandemic restrictions before we can start that system up. But it's there for on-site testing of 2 particular feedstocks, one of them cheese whey and the other one milk permeate, and it will allow us to assess the biogas production that we can get off that system, and therefore develop a very accurate design for a full-scale system for that site, and also allow us to develop predictive tests in the lab, so that when other people with similar feedstocks can come along, we can give them validated results from the laboratory. So that's just a brief introduction into the Envirotech modular multi-stage biodigester. It's designed to deliver value from waste streams, and by doing so, it's low cost, small footprint. So it's been developed as a local solution, and I encourage anybody who thinks that it may be of value to them to please contact us or myself at the details displayed there on the screen. So thank you.
Thanks very much, Richard. That looks like it's solving a lot of problems that are holding back biogas production, especially for those food manufacturers who don't have the space for a lagoon, or don't have a lagoon at the moment. So yeah, very interesting. One quick question before we move on. Rough cost for, say, a 300 cow dairy setup, what would be the rough cost of such a system? Any ideas on that one?
Yeah, well, I mean, it really depends on sort of what energy generation, etc., you'd want, and what the pre-processing is. But it would be between $500,000 and $750,000 sort of ballpark.
Yep. I guess if that's exporting electricity or a gas, then this is going to be quite a viable option. Great. Thanks very much, Richard. Much appreciated. Plenty of questions there. So we'll get to those towards the end. Maybe have a read through those, and we'll get through those when we finish the formal program at 5:30.
Okay.
Excellent. Craig from Optimal Group, would you like to take over? Now we've made some biogas. Maybe you could take us through what to do with that biogas. Just still on mute there, Craig.
Everybody hear me?
Sure can.
Okay, so, and has that screen come up?
That has come up. We're all good to go.
Good. Okay. Good afternoon, everybody. So my name is Craig Dugan. I'm the CEO of Optimal Group, and we are, well, we started off basically as a microturbine generator provider, but our business has morphed a bit since 2012 when we first formed. So, I'm just having, okay, so in-house we run a team of engineers, process engineers, chemical, mechanical, electrical. So we have a complete system design capability. We have a factory here as well, and we have a team of 15 service technicians nationally. so we work across a range of industries. We do a lot, obviously, in biogas, but we also do a lot with natural gas, with LPG, and now we're becoming quite active in hydrogen as well. So the technology that we, oh, hang on, beg my pardon. So the technology that we work with is the Capstone microturbine, and it is a unique piece of technology because it has one moving part. So the alternator, the generator, the alternator, the compressor and the rotor are all on one shaft, and maybe the best way if I can show that is by this next video. If it's going to play for me, right. So what you can see here, that's our 1 megawatt package, and it consists of 5 200 kilowatt turbines. You can see the single rotating part there. This is the alternator. So the air comes in, it runs over the alternator and it cools the alternator. It's compressed to about 6 bar. It's preheated in the recuperator. It's mixed with the fuel. Combustion occurs and it drives the turbine. That hot combustion air then comes back, passes through the other side of the recuperator, gives up some of its heat, and exits the turbine as hot air, 2% CO2 at about 290 degrees Celsius. So you can see it's very simple technology. We only make 3 engine sizes. We make a 30 kilowatt, a 65, and as you can see here on the screen, a 200 kilowatt, and then we build our systems up in multiples of those sizes. So one moving part, air bearings for the rotating part itself. So there's no lube oils. The bearings are basically a non-serviceable item. So every 40,000 hours, which is about 4 years operation, we will come and we will change the power head. The old power head goes back to the United States and is remanufactured, and we give you a new one. So you're not changing lube oils, you're not changing bearings, you're not changing spark plugs, and all those sorts of things that we'd be used to on conventional combustion engines. We have all of our, and because there's no lube oil systems or no cooling water systems, all of our waste heat is in the exhaust. So you can see here we have that's at 292 degrees, so we can do direct heating with that. We can do hot water, or we can do hot water to chilled water, or we can do steam. It's an expandable system, so you can see here 600 kilowatt package, 800 kilowatt package, 1 megawatt package, and for example, you could buy this package with only 3 turbines installed, 1, 2, 3. Keep these bays free, which could be populated at a later point. So we have turbines all through. There's about 500 turbines running in Australia. We've got a small number in New Zealand. We're just commissioning a 2 megawatt system for Fiji Water in Fiji. We've got a couple of units up in PNG. So we've got fairly good coverage through this region. We have full commissioning and service capability. We have 24/7 monitoring of our turbines, and this is our software package, which we call My Capstone Fleet. So that has full trending analysis. It has full tracking of spare parts that we use in the machines. Gives us full remote login and monitoring capability. So it tells you how much money your turbine's making for you. As I said, we have a call centre, so if you have a problem with a turbine, we can attend to it straight away. We carry about $2 million worth of spare parts here in Melbourne, but for critical power sites, and so we've got a number of oil and gas sites, we actually also hold spare parts at those sites. So why are we here? So we all know about climate change, and hopefully we're all doing something about it. So one of the interesting things that we see with, and this is across both the commercial sector and the industrial sector, that is where emissions are and how we can reduce it. So for example, here you can see in the commercial business sector, there are high CO2 emissions from buildings, and I guess this is something that's not a surprise. So for those buildings to reduce their emissions, it's often not simply a matter of buying green electricity. And it's even worse for industrial customers. So we're doing a job at McCain's at the moment in Ballarat. That's an 8 megawatt electrical, 25 megawatt thermal customer. So they want to go zero emissions, very easy to go and get green electricity contracts for their electricity. Currently, not possible to get rid of their emissions on their thermal side of things. What's interesting, if you hang on, let me just go back one. What's interesting, if you laid over this, you can see here this is Melbourne's main natural gas networks. So if I use McCain's as another example, if they were to go to the grid operator and say, we want to replace our boiler with a 25 megawatt electric boiler, the capacity is simply not there in the grid. So the only way that they'll ever be able to change their carbon footprint of their thermal is to get green gas. And green gas in our gas networks provides a fantastic way of delivering green energy, not only so you can get it through your poles and wires, but you can also get it through the existing gas infrastructure. So if we then take a quick look at what's happening with waste in Australia. Australia still sends over 40% of its solid waste to landfill. And if we compare that to Western Europe, they're at about 4%. So the difference in that is waste to energy. And as we know, when we put our waste in landfill sites and that material decomposes, it makes methane. It's a potent greenhouse gas. It also, you get a whole lot of groundwater contamination. But the crazy thing is that it's a magnificent source of energy that we should be making use of. So the opportunity to target that material and to be turning that material into green gas, we think is a huge opportunity. Let's go back and have a quick look at the building environment. So this is Collins Square in Melbourne. We power the whole of Collins Square with tri-generation systems. So in each of these towers, there's a 600 kilowatt tri-generation system where we've got 3 200 kilowatt gas turbines running on natural gas. We recover the waste heat to hot water, and some of that hot water makes chilled water. That's all for their air conditioning systems. Now, and their heating systems. So they've put 110 kilowatts of solar on one of those buildings, but that's still only a fraction of the building's demand. But if we were able to power those tri-gen systems with green gas, suddenly these buildings would become zero emission. And that is a target that we're working on with Walker Corporation, who own the buildings. So everyone knows that the price of natural gas in Australia is increasing, and you know, I don't believe that there's any government policy that's going to see that reducing anytime soon. But what that means is it creates a really interesting opportunity for biomethane. In fact, we're getting ready to launch our own biomethane business and get gas to grid, and we believe that you can build at grid scale. We believe you can build and be into the grid with wholesale gas at about $6 a gigajoule, which would in fact be cheaper than most current gas contracts that most current of our customers would be on. So if we see in Europe, this is, and you'll be able to get these slides later on, but in Europe this has been happening for a long time. So we're really well behind the curve in this regard, and so it's somewhat, I think this demonstrates that the business model is well and truly proven, and it's time to get at it in Australia. Now, one of the issues that we've seen with biogas, and I guess this is just focusing on when we see turbines, is that customers, and it's been mentioned earlier on, people, they generate their own biogas and site, okay, they want to make power. So you've got a choice between an engine and a turbine. And this choice sometimes is not as simple as it might appear. And in fact, there's a lot of biogas power projects in this country where the engines don't run. and they don't run for a whole range of reasons, and we'll go through some of those reasons today. So on the face of it, our open cycle efficiency is 33%. The nameplate efficiency of these gas engines looks really high at 44%. Same electrical capacity output, but hang on, here's an interesting factor. The gas turbine, our micro turbine package, we can run all the way down to 10% of its installed capacity. A gas engine will run to 50% of its installed capacity, and then it's off. So if your biogas production drops down below 50% of its normal capacity, you will have to flare that gas until it comes up to its capacity. The methane content is also very critical for engines, and if it changes typically by more than 10%, the engines will stall. Our micro turbines can run on anything from 52% to 100%. That change can occur on the run and nothing happens. In fact, at Western Water, we have an LPG injection system there, such that if the biogas production drops off, but they still want to run at 100% capacity, we inject LPG into the biogas to give them that capacity. This is a pretty detailed slide here, but what this slide shows, this is the operability window for this 1 megawatt turbine, right across the changes in biogas production and the power output that you want to run the turbines at. If you look at the same graph for the gas engine, for a 1 megawatt gas engine, you'll see that the operability window is substantially reduced. It's reduced because it can't run at below 50% methane production levels. It can't, if the gas concentration goes too high or goes too low, it can't run, etc., etc. So if you go back and think about that first slide where it showed that the efficiency of the gas engine is theoretically higher than ours, but if in fact by this slide you can see the engines are running potentially only 50% of the time, you can see that this is not simply a question of engine efficiency. The micro turbine, because it's made from exotic alloys, we can run on very high H2S levels without any change to our setup. So in fact, we'll run on 5,000 ppm H2S with zero removal of the H2S. Gas engines, if you do that, you have to be very careful with your exhaust systems. So you would typically start them on clean natural gas and shut them down on clean natural gas, and then have to monitor corrosion very carefully. Partial load. So again, this shows if you've got a micro turbine that you can meet much more of your power requirement from the turbine than you might with a similar sized gas engine. The other beauty about the micro turbine is it will respond instantaneously to changes in load, and because it's inverter based, it can be synchronized to solar, and there's no synchronization issues. We talked before about part load efficiency or part load capability. This is really important because biogas systems regularly go up and down across the course of the day as a result of different temperatures, different feed rates, etc., etc. So you've got to have a generation technology that can follow that gas production profile. So that means in our case that if it's that we won't need to flare any of the gas. You'll be able to use all of the gas, and you wouldn't need generally to put any storage on site either. You can just keep running all the time. Scheduled service, because we're 5 200 kilowatt turbines to make a 1 megawatt package, we have enormous availability for our system. So, and you can see that on the graph on the right. And if you think about it, we've got five rotating parts in that package. The worst case scenario is we blow a turbine, we lose 20% of the capacity. In a 1 megawatt gas engine, a V16 gas engine, you do a fan belt, a $200 fan belt, you lose 100% of the capacity. You do a spark plug, you do any single component on that engine, and generally speaking, you will lose 100% of its capability until you can get a technician out and with that part to replace it. That one of the other things that we then do is that we put most of our customers on a factory protection plan, which is a 10-year or 20-year fixed cost maintenance plan. So you pay a fixed cost per annum, and we do all the maintenance scheduled and unscheduled over the period of that FPP, and that includes all parts and all labour, and that includes at 40,000 hours, as I said earlier on, we change the power head, and we repeat that every 40,000 hours. At 20,000 hours, we replace the injectors, and there's a whole bunch of filters and other bits that we're regularly replacing. So that means that typically those components aren't failing and they're being changed before they fail, so we have very, very good uptime. So this is a project we're doing at the moment for McCain's in Ballarat. They produce 600 tonnes, or they take in 600 tonnes a day of potatoes, and they get 200 tonnes a day of waste. That's going into, currently it's going to anaerobic lagoons, but it will soon go into an anaerobic digester. That produces enough methane for us to run 2 600 kilowatt turbines, which is in fact six 200 kilowatt turbines, which is 1.2 megs. The waste heat from those turbines, the exhaust, we then direct that into their existing MaxiTherm 25 megawatt steam boiler. We're going to put a Saki high temperature, hot air fired burner into that boiler. So all of our exhaust will be used as combustion air in the boiler. That reduces the natural gas load on that boiler by 20%, and obviously delivers further greenhouse gas reductions to the customer. So, as I said, McCain's intend to go to zero emissions. So, in place right now, we've got they've put in a 7.6 megawatt solar array behind the meter. They've got the biodigester and our cogen system going in. They've got an additional off-site green PPA. They're doing some energy efficiency works. And then the next phase of this project, we're in planning to put a hydrogen electrolyser on site to make some hydrogen. That hydrogen, using green renewable electricity, that hydrogen will co-fire the boiler. Some of that hydrogen will also go to some local transport users, trucks and buses. And then the final part of the reduction will be green gas from the grid. And the only thing that's preventing them getting to this point is the green gas in the grid availability as we speak. So that's this is just a schematic of showing what we're going to do with the hydrogen. So some of the hydrogen will go into the turbines, as I said, and some of that hydrogen will also go to some trucks and buses. And the oxygen from the electrolyser is going to go to an adjacent sewage treatment plant, and that oxygen will potentially reduce their power consumption for aeration in that sewage treatment plant by 50%, or about 600 kilowatts. I'll just skip through that. One of the other technologies we have in-house is this Wastemaster technology, which is an on-site food dehydrator. That gives you another way of getting putrescible food waste deactivated, if you like, or sanitized so it doesn't smell, and dehydrated, and then that can be then trucked to an anaerobic digester, because it's great feedstock for anaerobic digesters. And then our model would then be that you do the anaerobic digester, you do a biogas upgrade, and into where we think the best way to go is to go into the secondary gas grid. This is the low pressure grid, so you have a lower injection component price, and then that can then go into the gas grid. How am I going for time, guys?
I think we're over time.
Okay, well, I might just stop it there and leave this. I'll leave the presentation available for people to download, and you can come back to me if anyone's got any questions.
Yeah, thanks so much, Craig. We hear when you talk about biogas, it quite often comes back to the problems with the gas engines. So this is great to see this as an alternative, and it looks like it's got an interesting operation envelope there as well. So thanks for that, Craig. Really. Edwina, we've got we've got the gas, we've just burnt it and created electricity and heat, and we need to run a biogas plant. And you're here today to tell us how that's done. So welcome, Edwina.
Thank you very much, Jared. Hello, everyone. My first disclaimer, I am not an engineer. After listening to Craig, I reckon I'm nowhere near as smart as he is. I would love to borrow him for a week on my farm and sort out a few problems. But I'm pretty good on pigs, and I'm actually an accountant by trade. So my story, my husband and I own a farm in the Young area. We have a 2,000 sow pig farm. That means at any point we have about 20,000 pigs on hand. It's split into two sites that are about 4 kilometres apart. This picture is of our grower site where most of the pigs are. Our pig sheds are 100% conventional. What that means is the pigs aren't on bedding, they're on a concrete floor, and the manure drops through a slat into a pit underneath where we can flush the manure into our digester. If we had our pigs on bedding, or if they were free range, you can't make power out of your manure. So that's one of the advantages of this style of farming. We feed our pigs 100% liquid feed, which is quite unusual to most other pig farmers. Most people feed their pigs something that looks like muesli. Ours comes out looking like porridge, and we pump it. We also have sheep and cattle, and we grow crops. Generally, we grow 50% of the grain we use to feed our pigs ourselves. We've had so much rain this year, I reckon we might be able to go close to doing 100%. Then again, last year, I think our sheep ate all our grain and we didn't get to give any to the pigs. So if you could flick over to the next slide, please.
Hi, I'm Edwina. I'm an Australian pig farmer. Being a pig farmer isn't just about looking after our animals, it's also looking after the environment too. Using this technology here, we've managed to reduce our emissions, save some money and generate carbon credits. On our farm, we capture the methane from our pig manure and turn it into electricity, which again powers our site. It all starts here. The manure from these pigs goes down into the pits and then is flushed into our pond where we capture the methane. The manure from the pigs ends up here in this dam. In fact, there's 15 million litres of it. The methane from the manure is captured underneath this cover and piped back up to the generator where it's turned into electricity. This project reduces the methane we release into the atmosphere. It was an initiative brought to us by Australian Pork Limited. It allows us to reduce our emissions, save money and generate carbon credits. Nothing goes to waste on our farm. We use other people's excess food products to feed our pigs, things like dairy products. These products would otherwise end up in landfill. Under our nutritionist's advice, we mix these products with grains, vitamins and minerals to feed our pigs a balanced diet. Like my kids, the pigs prefer chocolate ice cream. Like I said before, nothing goes to waste. Even the packaging is recycled.
I really love what we do. It is fantastic to be producing something that I know is sustainable and is really, good for the world. and to be doing our bit. So we've set up a system where we can capture our methane gas from our pig manure and turn it into electricity. It's fantastic because that was our 4th biggest cost, and we have now completely eliminated that and turned it into a revenue item. We also feed our pigs a lot of food waste. That's pretty exciting because it saves us buying a lot of grain. Last year we used 13,500 tonnes of food waste products, so things that would have otherwise gone to landfill. We can produce a lot of pork at a very affordable price. We can do it without a huge amount of land, using food waste, recycling our manure, even making our own electricity. So I think farms like ours are the answer to food security.
Kids, one of the things I was going to tell you about that I'm sure you didn't all know, that one thing even better than putting food waste into our digester to make power is feeding it to a pig, because then you turn the food waste into pork rather than just into fertiliser and power. So what we do on our farm, because we liquid feed our pigs, we can take a lot of food waste products to feed them. So every 12 months, on average, we would use 13,500 tonnes of food waste to feed our pigs. Now the big win of that is it means that the cost of our feed is about $80 a tonne less than the Australian average, which is, given that pig feed is our biggest expense, that's pretty significant. Some of the things we use day-old bread, we use fish fingers that have had something go wrong on the processing floor. We also feed our pigs pasta. Every day we get a semi-load of dairy product or juice that's had something go wrong with it. Generally, it's getting too close to its use-by date to go into a supermarket, so they send it to us. And we actually unpack a lot of these products, so we take them out of the milk containers and then feed it to our pigs. And then the manure heads into the digester. A piggery our size would normally use about 7,000 tonnes of grain a year, and we're only using 2,000 tonnes of grain a year. So we've offset a huge proportion of the grain we're using. Which is, it's a really exciting thing and makes us much more carbon friendly and profitable. But I know you're not all here to listen to me rubbish on about that. And if you flip over to the next slide, please. And now I'll tell you a little bit about our biogas plant. So we have 2 biogas systems. Unfortunately, you're not going to see too many pictures of them because they were all in the video. But they have, the biggest one of them is a dam that holds 15 megalitres, so 15 million litres of pig poo, and we capture the methane that comes out of that digester. We have a biological scrubber that helps to cool the gas and clean it. We also use a chiller and a conventional scrubber with iron peroxide pellets to clean the gas before it goes into our generator. We have between the 2 farms, we have 300 kilowatt, that's 3 units of 100 kilowatt generators. So they're only little. And we also use heat exchangers on them to heat hot water. And we use the hot water to then pipe it underneath where we have little baby pigs, and it helps keep them warm. And we're also using it for other, just recently we've set up a system where we can put the hot water through our pressure washers so it does a better job cleaning our sheds. We produce enough power to power our whole site, and we probably sell 50% of our electricity back into the grid. Mostly that's sold at night, and we probably produce more power in summer, so we sell more in summer as well. So I've put a few of the figures up here, the stats on it. The project overall cost us close to $1 million. But we did do it in the most expensive way. So what we did is, instead of just putting in one 200 kilowatt generator, we put in 2 100 kilowatt generators, thinking that in the summer we would run both of them and in the winter we'd run one. And that was more expensive than the single unit. In hindsight, we probably didn't need to do that because we ended up with more gas and more power than we expected. We also connected the 2 sites, so they're 4 kilometres apart on either side of the main road, and we had all of our manure and the most power at our grower site, but we don't use a lot of power there because there's not a lot of heating needed. But at our breeder site, where we don't have that much manure, will use a lot of electricity. So instead of transferring the power, we put in a pipeline and we blow gas 4 kilometres from one site to the other underneath the road. I remember with the council thinking, God, how am I going to talk them into letting us put a pipe under the road? It was all quite easy. We had to drill from our paddock to our paddock and miss the road underneath, but they made us have a stop and go man on the road, even though the trucks were on either side of the in our paddock. So anyway, the cost of it cost us $1 million. We save every year in not buying power, saves us about $250,000. We sell about $60,000 worth of power. We get to generate carbon credits because that methane is no longer going up into the environment. And as Richard said earlier, methane has a global warming potential 25 times worse than carbon dioxide. So all of that is not going, and we've been in fact, I say we're the first carbon farm in Australia, because when the Clean Energy Regulator started the carbon farming initiative, we were the second project registered, and the one before us was a landfill gas plant. And so I say we were the first farm. So we've been in that process from the beginning, and we're soon to come out of it actually, which is a pity. We also generate LGCs, and we do have a bit of maintenance. We probably spend between $120,000 to $150,000 on maintenance each year. We do a lot of it ourselves. We have guys that are welders and boiler makers, and they have just risen to the occasion with learning how to look after generators and a digestion system. We do get a specialist in probably every 6 months to do some of the bigger work. And sorry, the slide in front of you says that the big saving in this project for us was in not buying power. Selling power is like chicken feed in comparison to what it's saving us on our usage. And so the next one, please. It's not, we're always trying to improve things on our farm, but we certainly stuff things up a lot. So these were some pictures of some of the stuff ups we've had along the way. So the picture on the left of the digester or the covered pond, that was in really early days, and we actually used a different anchoring system to hold the cover down, and we had what I would call lay flat hose that was stitched together full of water as a weight to hold it down, and we'd filled it up, I think, from a water tanker initially, and some of the water had seeped out and we needed to fill it up, and my tight-ass husband said, I'm not going to buy pay for a water tanker, I'll just hook it up to the piggery water system. And there was so much pressure that we split the lay flat hose. That cost us 10 grand that day. Another one, our generators are in shipping containers. They came from China. They asked us what colour we wanted them, and I said, oh, olive green, that'll blend into the landscape. As you can see, they're nearly fluorescent green. Something went wrong in the translation. The bottom picture, we also had we flare some of our excess gas. We still have more gas than we can use sometimes in summer, and woke up in the middle of the night with someone ringing me up, there's a fire up near your pig farm. Turns out we've had a Christmas beetle fly through the flare, and must be the unluckiest Christmas beetle because the flame burns at 500 degrees, and it's managed to start a fire in the middle of summer. Thankfully, we'd had 5 mils of rain the day before, but right next to that's the bank leading up to the digester where we're holding all this flammable gas. So one of my guys, the guys who lives on our farm, was up there at midnight in his thongs and t-shirt, and he put it out without before any of the fire tankers got there. But it was a pretty, I think I aged a few days that night. Rightio, next slide, please. We've been very lucky. We've received some lovely accolades for some of the innovative things that we've done and the carbon-friendly things that we've done. We actually did a study last year on what our carbon footprint was, and discovered that we are, first of all, beef, you know, we're in competition selling pork with beef and lamb. Beef's carbon footprint's up here, lamb's about here, pork's down here, and on the pork we produce is 97%, has 97% lower carbon footprint than normal pork. So we're very close to being carbon neutral, which is something that we're aiming for, and then wondering how we might be able to market that as well. And then the final slide, please. and any chance to show a beautiful picture of my little son. You know, we're always aiming to provide a business that maybe one of our kids will want to take over, and I keep thinking we've just got to keep innovating and spending money and get better at it, otherwise we'll get spat out the other end. So far my 3 kids are all very keen on pigs. They don't like the generators so much. I think their father makes them hang around there too much when he's trying to do something on it. And that's it. Thank you.
Fantastic. Thank you so much, Edwina. And I think I've got about 50 questions, and I'm sure we'll have another 50 coming. We'll get to those in just a moment. And just on the colour of those generators, I mean, I know you didn't get olive green, but I think you got A2EP green, so I guess that's not there anyway. John, you're with us, and tell us about, I've introduced the CRC a little bit earlier, but if you could give us a quick overview of the CRC.
Sure.
Let us know then, you know, what's available to try and pursue and get these sorts of projects moving in terms of some government funded programs and whatever.
Sure, happy to do that. Just can't see the slides at the moment, but
yeah, that's not coming through. We've just got yourself there.
Yeah, no matter, I will just talk. So just to introduce very quickly what we're doing, we're the Race for 2030 CRC, which is reliable, affordable, clean energy, and A2EP is a member, as are 90 other organisations joining up at present. We've got quite a large resource, probably $160 million of cash, and probably $360 cash and in kind to expend on reliable, affordable, clean energy projects by 2030. We are very focused on energy productivity, so we have a natural linkage with the Alliance. We started actually in about 6 weeks ago officially, on July the 8th. And as I said, we've got 90 members in the organisation. We've got 4 major research programs. One of them is Race for Business. And in Race for Business, there's one of the key 5 programs is on biogas. I'm just wondering if those slides are up then. If they're not, don't worry about it. I'll just keep going. The biogas project has got a range of deliverables for the Commonwealth. Plus, we've got a whole range of projects that are of interest to our members. So we're kicking off in the next probably 9 months. We'll be doing a big scoping report on international best practice and defining gaps to commercialise anaerobic digestion for processing organic waste and for the water industry and co-processing. We'll be doing some pilot projects. We'll be developing roadmap and reporting on pilot projects through this period. The best way to get involved in Race for 2030, if you're not an existing member, is through A2EP membership, and Jared's heavily involved with us in the program. So there'll be as I said, biogas will probably be kicking off as a focus in about 9 months' time. But we're open to project proposals, and what we're all about is collaborative projects, which include industry, which include technology companies, often government, and researchers. So we're bringing together that sort of collaboration to deliver benefits, and we're all about impact. This is not a sort of general, theoretical research. Most of the stuff that we're doing is at the commercialisation and demonstration level, and we're looking for great projects to turn into impact in terms of reduced carbon emissions and reduced energy costs. And that's all I wanted to say at this stage, but I'm happy to answer questions.
Yeah, thank you, John. And I guess one example of that, and going back to some questions we've had, would be something like the Gaia technology, the modular biogas, and supporting that to go across and be tested in other applications, abattoirs or something like that. Is that sort of the thing that the pilot projects would be supporting?
Yeah, our focus is on biogas in the manufacturing sector, the agricultural sector, and also in the water industry. And so very interested in the conversion of materials that on farms that are not currently being converted to biogas, where there's some innovation required to make them commercial, but also in manufacturing and water.
Great.
Enhancing biogas generation in the water industry.
Thanks, John. I think that's certainly needed to get some scale, some of this production at scale. So that's great. Thank you. And just before sorry, we are over time. I'm just going to finish off with a little bit about A2EP and what's coming up, and then we'll get to try and get through some questions. And we'll again capture those questions, and we'll have them sent out as well, in case you can't stay on any further. Just there for A2EP, I just want to let you know about what's coming up for A2EP. The 3rd of September, we're building on our process heating webinars that we've been doing this quarter, and we're doing a specialised one on heat pumps, high temperature heat pumps. We've got an expert from Switzerland, Dr. Corden Arpagos, and he's going to take us through the different advances over the last few years in terms of refrigerant applications and what have you for heat pumps. So please put that one in your calendar. You can find that registration there via our LinkedIn page. A few other ones to bring your attention to. We've also got the heat pump selection guide coming out on the 8th of October. More on technologies on metering and measuring on the 15th of October, and then our main annual event on the 9th of November, our Innovation Exchange Conference. So plenty there coming up from you for A2EP for you. In the meantime, if you want more A2EP, sorry, just before we go to that, I just want to share another event going on. If you go to the next slide there, there is a nice event being run by New South Wales DPI there on Beyond Diesel. There is a huge requirement for the agricultural sector to move beyond diesel, and there's a great program coming up on Wednesday, the 2nd of September, to find out the different options and ways to do that. So you'll have the link here in the package that comes out to you shortly, and yeah, I encourage everyone to go along to this event, as I will be. If you did want more A2EP, the best way to grab us is via LinkedIn. We don't like to be emailing you every other day, so the best way to get us, go to LinkedIn, just type A2EP, we'll come up, and if you follow us from there, that's a great way to get updates from ourselves whenever you log into A2EP, into LinkedIn, sorry. Good. With that, we're going to get into some Q&A there, just those questions. And again, for those that some people may have to drop out now, thank you very much for joining us. If you can stay on, great, we'll get through it. Thank you very much to our speakers. I'll say that now while everyone's online. But meanwhile, let's try and get through a few of the questions here. Richard, I hope you've been reading the questions. There's a bit of a $64 million question here for you about the Bungaree Dairy Farm. From Liz Hamilton, had heard that there's some issues with profitability of the power generation and site. Richard, you got a bit of an update there for us? What's going on there at site? Oh, just on mute there, Richard.
Yeah, sorry about that. Yeah, so the Bungaree site is our pilot plant. So we've been running that now for a couple of years. And so firstly, that system's owned by Gecko Systems. And what we've been doing, I've got some data here that I can show later if people are interested, is throughout last year, we were optimising that system while we were doing that, increasing the feedstock into it. So we actually we managed to increase the amount of feed that we could put into that system to the level where we could take away one of the stacks. So we originally put 6 cells out there to process the feed material from that farm, and we optimised it to the point where we could take 3 of those away, and we're redeploying those to another site at the moment. Someone's purchased those system. So effectively, we've optimised it. We were looking at uptime, etc., which I think there was a question on, and I can show you data, but that's in the high 90%. But what we did do when we optimised it was we started pushing some of the gas management stuff to its design limits. So at the moment, that system is at a point where we're we're making a decision really about whether we upgrade it to their latest model, which is our design, which is the systems that are the other systems we have. And if we're doing that, we would connect it up to the grid and sell electricity to the farm. So it's a very complex situation. The selling electricity to the farm on its own, just as that system is profitable. We could do that. The question for us really, is there a better use for that system? Could we use it for different feedstocks, etc.? And
I guess it sounds like this is in a ramp up phase, and to be judging on profitability at the moment, where you're at, it's probably not the right time to be doing that. Maybe once things settle down and you look at next stages of production and further optimization, no doubt that would be a better time to judge the profitability on that, no doubt.
For the electricity, yes. There's also there's a lot of soil conditioner and things that come out of that system, which the local farm uses themselves, which we don't sell. Now, if we sold that externally, again, there'd be a very good revenue stream associated with that.
And are you getting a strong handle on where the CapEx is headed for the plant? And the question here from Barry Plate is how does that compare to a standard anaerobic lagoon type setup in terms of the CapEx?
I don't know, it might be a better question for Edwina. I'm not sure. I know she mentioned $1 million for her system, but was that from building it from scratch, Edwina, or building ponds and the full infrastructure? Yeah,
that was building ponds, buying the generators, putting all the electrical work in, putting the 4 kilometres of pipe in under the road, everything.
So I'd have to look at the size of the system, but looking at that, I'd say in that case it'd be comparable, I would have thought. But with I think you said $150,000 sort of maintenance per annum on that system. I think the Gaia systems don't require that sort of attention at all in terms of upkeep. So I don't know whether that relates to maintaining ponds and things or what.
It's for the gen sets as well there, that 120 to 150K there. And you've had a few larger costs there in the generators as well there, Edwina, if I recall earlier discussions.
Yeah, mostly there's pretty much a zero expenditure on the ponds. There's a bit electrically, and a lot of it's been on generators, and having to get an expensive mechanic to come from Queensland to help us with it. But that reduces each year, and we've replaced generators. We've been going since 2011. So we have had to do, some big engine overhauls and engine replacements and things like that.
Yeah, that's expected, I would have thought.
There's questions about sort of the feasibility, Richard, of the herd size and things like that, because I know for a 300 cow dairy, I think the numbers are around $30,000-$40,000 of energy costs per year, and at $500,000, that's looking a bit of a stretch and potential long payback. Have you done much modelling on different size of the herd where the technology is most appropriate?
Well, it really depends on the end users. So we have, we've spoken to people who are burning diesel to make electricity, so the cost of their power is a lot more than standard grid charges. Whether they have waste management costs is another one. As I say, the Bungaree farm is using the soil conditioner, etc., for their own. They grow crops and things out there, so they use it on their own paddocks. But if we were selling that externally, it would be a considerable amount of money coming in from that. So it really depends on the situation that each business finds themselves in terms of their cost structures and waste management problems. And the other thing is, I mean, manure is a quite low energy value product. We're having discussions with a food manufacturer at the moment who they have a byproduct coming out of their processing plant, which we could supply. I think it's over $1 million of payback to them a year in terms of energy, and that would have a payback of 6 years or so. So it really depends on what the feedstock is and what the energy costs and other variables in the equation are.
It does seem to have some similarities with the ARENA studies we're doing, where it seemed quite essential that you look at non-energy benefits as well. And as like Edwina said, with I think is odour and getting rid of that and solving a wastewater problem, and it all seems to be, it needs to be a combination to really see these sorts of projects go ahead. Richard, still more questions, plenty coming in for yourself about expected downtime for the unit, and how much usable biogas, either sort of gigajoules or standard meters cube, would you get out of that 6-stack system?
Well, how much gas you get out really depends on the feedstock you put into it. So I'll give you an example where the system we're just preparing to ship now is going to a transport company, and they'll put in sort of leftover food waste and things, and we would say that that's going to be a 3-stack system to start with, and they've set it up to drop in another stack later on. And I would expect from that, when they have the 2 stacks, so the 6 cells operating, it'd be well over 1,000 cubes a day of biogas coming off that feedstock. You wouldn't get that much biogas, say if you were feeding it just pure cow manure. If it was a cow manure mixed with something else, then it can be much, you can enhance it. So for example, we've looked at mixing manure and milk whey together. It gives you quite good biogas production.
Okay. And the downtime, maybe that's something for Edwina to look at, answer first, a sort of downtime, unplanned maintenance and unplanned faults. How often are you seeing that? How often are you getting the wake up at 1 AM to put out?
Well, that's one of my other jokes, is that when we first put in our methane digestion system, we had little kids, and I would swear my husband would only hear the alarms for the generators. He never heard a crying baby, only ever the text message. We used to, it was a rough 18-month learning period. We've got really good at it now, and we barely get, we don't have very many stops. We sometimes have to stop it for a day for routine maintenance. We actually now have a backup generator, so we can often just switch over to the other generator. So we manage that pretty well. But look, it was pretty hard going at the beginning when, I'm sure we did everything wrong that we could, but we've learned a lot by doing that.
I'd say 18 months to get up to speed and iron out the problems. That seems pretty typical and pretty reasonable. Got a question from Liz Hamilton. If all houses in a new housing estate could be fitted with something like an incinerator, could one of these digesters, so obviously then to you, Richard, be used to handle housing estate sized waste, something like a centralised repository there? Maybe topped up with another uniform substrate to help reduce the issues of having non-uniform waste streams with variable digestible properties. So something like an enriched sewage for the digester, no transport, and basically local, local sewage treatment you'd end up being supplying there. Richard, have you guys looked at that at all?
Yeah, we have. We've had a few requests around those sort of systems, and so definitely doable. And then I guess the question comes down to, as we've been discussing a little bit, the drivers for doing that. So if, depending on whether it's a sort of a waste management solution or whether it's there purely for generating income, etc., and it needs profitability from that, then that will kind of dictate, I guess, the size of the system, and also the availability and cost of power locally, etc., the disposal costs if you didn't have such a system there, etc., all go into that equation.
I think once again the compact size of it and the potential there is possibly the game changer.
Yeah, but in terms of footprint and being able to locate it, not a problem. Yeah.
Another question for you, Richard. It keeps coming in here. The fertilizer byproduct, how's the value of that compared to, say, biomethane? Assuming you've got a nutrient-dense feedstock like food waste, what's the value of that fertilizer byproduct?
It depends. Again, it's sort of, so the pilot system that we have that we were running out at Bungaree, we had an offer there from a person who kind of had a business which upgraded that sort of material into kind of potty mix and whatnot, and so that was it's quite profitable in terms of that. But if selling it to farmers, etc., I haven't been involved in that side of it, so I can't give you a real answer. But it's nitrogen and phosphorus rich material, and I don't know what the price is of that at the moment.
Yeah. And I've got a question about the low cost and paybacks and things like that, but it sounds like it might be a bit early to you to be able to answer that one, Richard, to say, bang, this is it. So we might skip over that one. Edwina, your video that we unfortunately couldn't show, and apologies for that. Oh, on mute.
Sorry, I'll find the link and I'll email it to you, Jared.
Great. Yes, we'll send that around, make sure people have a chance to see. That's a really great, only a 2-minute video, but it's fantastic to see. Good. Thank you. Oh, thank you. Yes, thank you, Scott. Edwina, props to you. The snaps for you. They're loving the story. Good. Okay, I think we're getting down to some other questions. I think we've touched on a lot of this for the moment. Good. I think, yeah, look, just flicking through, I think we've covered a lot of the questions now already, so I think we could probably leave it there. Edwina, as I said, I'd love to go for another 20 minutes or half and a couple of hours with more questions on how you ramp all the challenges and things you've had. Maybe if I just finished with just sort of one question to finish off with you, Edwina. You know, what are you? Going on your own journey here, you know, what advice would you have to other businesses that were looking something similar to you?
Oh, well, I'm an accountant, so I love the numbers, and you know, it's exciting that we managed to get a project off the ground that, you know, we've really turned one. I think it was our 4th biggest expense, and that is now a revenue item. So that's pretty hard to beat. And getting the carbon credits and the LGCs has all been icing on the cake. But the fundamental thing is we are now an exporter of power, and we don't have to purchase it. We're doing a better job for the environment. We've reduced our odour. It's just such a win-win project that it's, you know, I'm sometimes flabbergasted that when I hear of other farmers who haven't installed a system.
Yeah. What are they waiting for?
Yeah, and I know it's hard work, and I think the barrier to entry is actually us all being too busy and having too many other balls in the air, and also probably the fear of the unknown. You know, it's a big project to take on, and I'm very lucky that my dad, who's zero university education or anything like that, but was a sort of a frustrated engineer really, and he got a long way to doing the planning for us, and just kept kicking it along and what got it going. So I still get excited when I get every month when we get paid for our power and I don't have to pay a bill.
Brilliant. So it sounds like Dad was the site champion there to get things moving.
Yeah, definitely, definitely. He's the most driven person, and I'd be thinking, oh God, he's going to ring me up and ask me, have I done something? So I better get it done before he's hassling me.
Very good. Well, to our speakers, thank you so much for making this event what it is. Yeah, we look forward to welcoming the audience back in just a few weeks' time for the heat pump seminar we got coming up. Otherwise, thank you all very much. Have a great evening and hope to see you again soon.
Thanks, Jared.
Thank you.